Hello, everybody. I'm hoping to make it through this lesson. It is very stormy, wintry day out there. Power has already gone out today, and it's flickered on and off a few times. Okay, let's get started without further ado. The silence at the beginning is as per usual. Still haven't got this totally dialed in. So just making sure we're up and running before I spent an hour doing this and then realized that it was all for naught. So today we want to do some exponents and some square roots. So we're going to learn some exponential notation. Well, I'm going to learn. You may learn if you're watching. Positive integer exponents. So if a number is repeated as a factor numerous times, then we can write the product in a more compact form using expressional notation. So for example, if we had 3, that is the wrong one, 3 times 3 times 3 times 3 times 3. We can rewrite that as 3. 1, 2, 3, 4, 5. 3 to the 5th. So we could also write 10 times 10. We can rewrite it as 10 squared. That would equal 100. Let's see if we can figure this out in our head. 3 times 3 is 9, times 3 is 27. It's already too big. I don't want to do it. I think 27 times 3 is what? 81. So then the answer would be 81 times 3. So a little formula for this, if we have a, so the n is going to equal a times a dot 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 times a I wonder if I can move this. N factors so basically what I showed up here, if you have 10 times 10, that's the same as 10 to the square, 10 squared, or 10 to the second. And then 3 times 3 times 3 times 3 times 3 equals 3 to the 5th. So, like I said about the 10 times 10, if we do something like 3 times 3, that's the same as 3 squared. That equals 9. So whenever you see 2 for the exponent, that means we're squaring. We're multiplying by itself. And if you see a 3, 3 to the third, or 4 to the third, or whatever number, that's the same as 3 times 3 times 3, and that's going to equal 27. And then 4 to the third would be the same thing. That is the equivalent of 4 times 4 times 4. So the number, the main integer, is the base. Okay, and then the number above, floating above, is the exponent. So if you have 10 to the fourth, 10 is the base. Four is the exponent. Boom, there you go. So let's do another example here. So the base can be any real number. So 3.2 can be squared or cubed or whatever. And that would be the same as the examples above. That would just be 3.2 times 3.2. And that equals 10.24. We can also have, say, 3/5. If we squared 3/5, we would come up with 3/5 times 3/5. Remember, in multiplication, we multiply numerator and the denominator. Because they're both the same. And that's as much as it can reduce. Now how about a negative number? -7 squared. What are we going to get? We're going to get -7 multiplied by -7. And we know that equals 49. Now, look at something a little bit different here, though. What if we have -5 squared? What do we get here? Well, we're going to get -5 multiplied by 5, and that's going to equal -25. So it's important to notice how these two are different. So when you have the parentheses around the -7, the base is -7. No parentheses, The base is just the 5. So the result will remain negative. Let's see if you get a better example here. Negative 5. Oops. Here, I want you to be able to see this. So this, even though it's a easy thing you can skip over, you still need to pay attention to that because it determines the sign of the result. So another thing you might see in calculators, if you're using a calculator to do this, how do you write 8 squared? Some calculators you may have a button like this. So you would write 8, and then you would do this little, it's like a cat ear, a little arrow pointing upwards. 8, 2. And those will equal the same thing on your calculator. Here's another problem we can do. So right here, you're probably going to need to do work. But you would just do this. One times 1 is 1, 5. 5 times 1 is 5. 25. 1, 10, 1, 6, 2. Let's see, how many numbers are to the right of the decimal? 2. So 1, 2, so 26.01. Remember there's a negative, so bring down the negative. Boom, there's your answer. So the square of an integer is called a perfect square. So for example, 1 times 1 equals 1. So you want to see why we're staying away from x now. Using x as a multiplication symbol, because look what this could be misinterpreted as the absolute value of x. So when you're doing 1 times 1, you want to do, or anything for that matter, 1 dot 1 or 1 parentheses 1. Or you can put them both in parentheses. So 4 is a perfect square because 2 times 2. 9 is a perfect square. 3 times 3. 16 is a perfect square. It's 4 times 4. 5 squared is 25. then 6 squared. So knowing the perfect squares is helpful. If you could learn like the first, 15 of them. So you'd have perfect square of 1 is 1, perfect square of 2 is 4. So 3 squared equals the perfect square of 9. 16 is the perfect square of 4. 25 is the perfect square of 5. 36 is the perfect square of 6, and then so on. 49 is 7. 8 is 64. 9 is 81. 10 is 100. 11 times 11 is 121. 12 times 12 is 144. 13 times 13 is 169. 14 times 14 is 196. And 225, it comes from 25 squared. 25 squared, 15 squared. So what if we saw what would we have here? Since it's in parentheses, we have negative 12 times negative 12. Two negatives multiplied equal positive. 12 squared is 144. So now if we have, so when we see the exponent as being a 2, we can say it's squared. When we see the exponent being a 3, then it's cubed. And then you're doing, instead of stopping at 3 times 3, that would be the square. So 3 cubed equals 27. 3 times 3 is 9. 9 times 3 is 27. So now we have 2/5 cubed. What does that equal? 2, 5. And we know multiplication of fractions. We have a common denominator, so 2. Don't make the mistake of going 2, 4, 6. This is multiplication, so 2 times 2 is 4, times 2 is 8. And then 5 times 5 times 5. So 5 times 5 is 25, times 5 is 125. So not only do you know what 2/5 cubed is, 8 1/25, you also know that 2 cubed is 8 and 5 cubed is 125. Now let's say you have -7 cubed. What's that going to equal? Oh, you're in parentheses here, so the whole base is negative. And then what do we know about multiplying negatives? A negative times a negative is positive. So is the answer going to be positive? No, it will be negative because we have negative times a negative equals a positive number times a negative. A positive times a negative becomes negative. So it'll be -343. So just to clear that up, so you have negative x times negative x. By the rule of multiplication, you get a positive result here. So now you have a positive x, and you're going to multiply that by a negative x. And we know positive times negative equals negative. Now, realistically, these this shouldn't be x, this shouldn't be x, because, but just for so perfect cubes are the results you get when you cube a number. So just like perfect square, like 16 was when you squared 4. Perfect cubes are when you cube an integer. So like 2 cubed is 8. So 8 is a perfect cube of 2. So 1, what do you think? So 1 cubed is equal to 1, because that's 1 times 1 times 1. 2 cubed is equal to 8, because that's 2 times 2 times 2. 3 cubed is equal to 27. 4 cubed is equal to 64. 5 cubed is equal, whoops, I put squared up here. Equals 125. So then 6 cubed would be 216, 7 cubed would be 343, 8 cubed would be 512, 9 cubed is 729, and 10 cubed is 1000. So for instance, if you had negative 2 in parentheses cubed, you would have negative 2 times negative 2 times negative 2. That's going to equal negative 8. Remember, negative times negative is positive. Now it's times negative again, so back to negative. So once we get past 3 as an exponent, everything after that is to the nth power. So 4 squared, 4 cubed, 4 to the 4th, 5 to the 5th, 5 to the 6th, 5 to the 7th, it'd be the 8th to the 9th to the 10th to the 11th. So if you have 10 to the 6th, that's going to equal 10 times 10 times 10 times 10 times 10 times 10. Now, an easy way when you're dealing with 10, squaring 10, or working with exponents, you're just going to have 1 and then the number of zeros. 1, 2, 3, 4, 5, 6. There you go. The answer, 10 to the 6th is 1 million. So if you have negative 1, and you got it to the 4th, what's going to happen here? You have negative 1 times negative 1. I need to get this a little thicker here. times negative 1 times negative 1. Now you're going to have a situation where you have negative times a negative equals positive. Positive times a negative is going to equal a negative. Now negative to a negative, negative times a negative becomes positive again. So your answer is going to be 1. Positive 1. Okay, so far the examples, it's a little bit repetitious, but I think that's fine. Repetition is actually good when it comes to these things. It helps you memorize. So what's that going to be? It's going to be so your answer is going to be what? Because you are squaring, you have an odd number as an exponent with a negative base, your answer will be odd. If it's an even number, let's say this was 4, you had another negative 13, now your answer would be positive. Negative times a negative equals a positive, times a negative equals a negative, times a negative equals a positive. So a negative base with a odd exponent, you're going to get a negative answer. A negative base with an even exponent, you're going to get a positive answer. Here, let's make this something we can actually do. Let's switch this to a negative 1/3. So you'd get negative 1/3 times negative 1/3 times negative 1/3. You're going to get negative 127. 3 times 3 times 3 is 27. Negative times negative is positive times negative. Makes that negative. Let's do a couple more and then we'll move on to square roots. What if we had negative 10 to the 4th? Well, remember, 10 is the base here. So we can basically write negative 1 times 10 times 10 times 10 times 10. And we end up getting, let's see, what is that going to be? How many zeros? 4 zeros. Well, 10 times 10 is 100. So 4 zeros gives us 10,000 times negative 1. It's going to be negative 10,000. And then if we have the base of, in parentheses, well, now we know the base is negative. So our answer will be 10,000 because the exponent is even. If the exponent was 5, then we'd have negative 100,000. So square root of the real number. This is stuff right here. It's stuff you're going to notice more. The beginning was mostly addition and subtraction. Yeah, you're going to see that and everything, but you don't notice it because you're so used to it. This is, I think, where we start seeing things where we notice them once we get into higher levels of math. So the square root basically is the inverse of squaring a number. So we learned that 5 squared is equal to 25. We also learned that negative 5. So we know these two equations to be true. So now how do we get to the inverse of that? So if we have a squared equals a, if a is greater than or equal to 0. So we also have a squared equals the absolute value of a. So as an example, the square root of 25 is equal to 5. So how do we plug this back into the formula? So 5 would be a, and a squared, which would be 5 squared, is equal to 25. So therefore, the square root of 16 is equal to 4. And we know that because 4 times 4, or the square root of 4 equals 16. Or 4 squared. The square root of 4 is actually 2. So the square root of 16 is equal to 4. Also, the square root of 1 is equal to 1. Why is that? Because 1 times 1 equals 1. So 1 with any amount of exponents. So 1 to the 1063rd equals 1. 0 squared equals 0. Now let's see what happens if we have square root of 10,000. Well, we know that's going to equal 100 squared. That's going to equal 100. Now, one thing, a rule with when you're dealing with 10, 100, 1,000, anything 1 with trailing zeros, square root is half the amount of zeros. So for instance, 1,000 squared is equal to 1,000 times 1,000. How many zeros is that? 6. So it's going to equal square root of a million would be 1,000. So you have the amount of zeros 6. Anyway, let's move on. So let's simplify. 1/9 squared. And what is that going to equal? That is going to equal the square root of 1/3, which equals 1/3. So if we have something like this, a times b is equal to, or the square root of a times b is equal to the square root of a times the square root of b. So why is that important? Because when we have something like square root of 8, well, 8 doesn't have a square root or a perfect square root, perfect square factor. 8 is not a perfect square. So we can break this down to a product of perfect squares, though. So this will equal, remember when we broke things down before, what does 8 break down to? 4 and 2. Okay, those are both perfect, or I forgot the term. Darn it. Guess you're not learning from me. Anyway, so that'd give us so we know the square root of 4 is going to be 2. The square root of 2 is broken down as far as we're going to get. So the square root of 8 is going to be 2 squared 2. So that's a simplified irrational number. But you're often asked to round a certain decimal place. In that case, we would use the calculator. Just use the calculator to find the decimal approximation. So you can reduce this to approximately 2.83. Okay, let's do square root of 75. So let's factor this, and we're going to end up with 25 times 3. Now we can separate 25. Now we know 25 is a perfect square of 5. So the answer now is 5 root 3. And then that approximates to 8.66. let's try 180. 180 comes out to, let's see, 5 goes in there 36 times. That's actually perfect, because 6 is a perfect square, so we're going to get 6 root 5. Now what happens if we have something like this? Negative 5 root 162. So we're going to have negative 5. Let's see, 162 is 81 times 2. 81 is a perfect square, so we'll have negative 5 times this is not a negative sign. So square root of 81 is 9. Then we're going to have square root of 2. So we should end up with negative 5 times 9 is negative 45 root 2. Okay, let's get some fun stuff here. Here's some, now the real algebra starting. So we know a right triangle is a triangle where one of the angles measures 90 degrees. It's a perfect right angle. That would be 90 degrees. From flat to flat is 180. 270, 360. So a perfect square is 90 degrees. So a right triangle is a triangle where one of the angles measures 90 degrees. The side opposite the right angle is called the hypotenuse. So opposite the right angle, the line that goes this way, that is the hypotenuse. Hypotenuse. The other two sides are called legs. So this is a leg, this is a leg. So the Pythagorean theorem states that given any right triangle with legs measuring a and b units, the square of the measure of the hypotenuse c, so this is a, this is b, this is c, is equal to the sum of the squares of the measures of the legs. So therefore we end up with a squared plus b squared is equal to c squared. So in other words, the hypotenuse of any right triangle is equal to the square root of the sum of the square of its legs. So, as an example, let's say we have a triangle. We have A here, B here. We know it's a right angle because we're going to draw that in there. That indicates that this is a 90-degree angle. So A squared plus B squared equals C squared. Or we could write it as C is equal to the square root of A squared plus B squared. So if the legs measure 3 and 4 units, so we'd have 3 squared plus 4 squared so on this we'll have a is equal to 3, b is equal to 4. So let's use c is equal to 3 squared plus b squared. Oh, b squared is 4. So we know that 3 squared is 9. 4 squared is 16. 9 plus 16 is 25. And the square root of 25 is 5. So c is equal to 5. So let's do this triangle. We have a triangle here. It's going to be a right angle. We're going to have 2, and we're going to have 6, and we need to know what c is. So we're going to end up with c is equal to the square root of 2 squared plus 6 squared. So 2 squared is 4. 6 squared is 36. So we're going to equal square root of 40. So now let's factor out. Perfect square in here would be 4 times 10. We'd end up with square root of 4 times square root of 10 is equal to square root of 4 is 2 root 10. All right, so I think that's going to kind of wrap it up. I think we got enough examples in there. So just remember, when you see an exponential notation, a is the base, n is the exponent, or the base is used as a factor n times. So when the exponent is 2, when n equals 2, we say that's squared. When n equals 3, we say that's cubed. Try and work on memorizing the squares of integers up to 15. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, etc. up to 15. When negative numbers are involved, take care to associate exponent with the correct base. So parentheses group a negative to the base. No parentheses don't. So if you saw negative 10 squared, that means the base is negative. If you just saw negative 10 squared, that means 10 is the base, not the negative. So remember, a negative base raised to an odd power will be a negative. Negative base raised to an even power is positive. The square root of a number is a number that when squared results in the original number. So the square root of 16 is equal to 4, and we know that because when 4 is squared, it equals 16. And I think one of the bigger takeaways in this lesson is this. This is barely touched on. They have to touch on it some more. But you are going to use this a lot, or this is going to start coming up a lot. So this is going to be really important. If you take away anything from this, take away this. And that'll do it. Till next time. So when the next time we're here or I do this, we'll do the order of operations. That should be pretty quick. Order of operations for most people. Ped mas. And if I got this wrong, we'll find out next time.